Okay, next we will be covering with some of the concepts that are small concepts, but they have been usually asked for 5 marks or 8 marks, 5 to 8 marks maximum. So here the main concepts are the small concepts, or they can be asked in as a differences also, or write a note also. So we have those concepts called as multiprogramming, multitasking, and multiprocessing. Now, what's the difference, or how we can differentiate or write it on our own? Firstly, we will start with multiprogramming. Now, when I say multiprogramming, programs are multiples, correct? So when I say programs, or these programs can be nothing but the processes. Okay, if I take multiple processes that are waiting in your main memory, okay, I mean the secondary memory, and they are being loaded into your main memory because they are about to execute. Now when we are working with multi-programming, now, what do you mean by multi-programming? We have a CPU. Suppose we say processor P2 is the one that needs to be executed first. So that will be loaded into your main memory, and the CPU will start executing the processor P2. Now, while it was executing, say suppose it executed for say about a minute or 2 minutes, and after 2 minutes it was in a need of input output operation. Okay, like say suppose something, uh, some inputs or the keyboard devices was needed. Now while it was in need of input output operation, the CPU was remaining idle, correct? So the CPU cannot remain idle because we need to have an increased performance or the CPU utilization, correct? So that time I will make say processor P1 or a P3 come here and start executing. So we cannot forcefully remove the process P2 and make the process P1 start executing in between only. It's only because I got an interrupt of say process P2 was in need of input output operations to be performed. So it came out of the CPU, and when it is out of the CPU, I am getting the next process into the processes. Okay, so multi-programming, that is multiple processes can be executed. But what's the disadvantage of multi-programming? As we saw here, when the process P2 was executing, we cannot forcefully remove process P2. Okay, we cannot forcefully remove your process P2 and make your process P1. So that's the reason, if what the processor P2 was taking a longer time or more time to execute, and there was no any interrupt for the process P2. Okay, so P1 and P3 would never get a chance to execute. I mean, maybe it may take a more time. Though say the execution time of process P1 was say 1 minute, and execution time of process P3 was 2 minutes only, or we can say it is in a seconds. But process P2 was the highest priority, and it had a execution time of 5 seconds. So it is so much time that the process P1 has to wait. Say if I say 15 seconds, so for 14 seconds the process P1 have to wait for its turn to execute. So that's what your main disadvantage in multi-programming is. Okay, so you got to know I can execute multiple programs, but to increase the CPU utilization, which increases the CPU utilization. Okay, so we can here also write one of the points, say that the degree of multi-programming is directly proportional to the CPU's performance. Okay, like as in how I increase the number of programs or the processes to be execute, I am keeping my CPU more busy. I am not making my CPU idle. So if I am making my CPU busy, then my CPU utilization is increased. Now coming to the next is your multitasking. Now what do you mean by multitasking. Here always remember T, that is tasking, as time sharing. T for time. So multiprogramming, multiple processes, multitasking, that is time sharing. This is also called as time sharing. So why am I calling this as a time sharing? Let me take the same example here. If say suppose process P1, P2 and P3 are here, and we are making these processes to execute in particular time. Now here what we did in multiprogramming, we first loaded the process P2, maybe it had a highest priority, and it was executing and executing. It took 14-15 seconds to complete. Till then process P1 has to wait, correct? So that starvation was generated here. But here as in multitasking, what we are avoiding is, like as we said, process P2 was about to execute because it has a highest priority. Now here I will be giving a time quantum. That is, I'm going to make each process to execute for that particular amount of time only. So say for 2 seconds. So now process P2 will execute for 2 seconds, and then say suppose P1 was the next priority, then P1 will come, then next P3 will be coming. So they are all in the ready queue, that is in the main memory, to start executing. Now though it is of 15 seconds and though it is of say 1 second and 2 seconds, they are able to execute now. They need not wait for a longer time. So here what are we doing? Forcefully we are removing the process P2 and we are getting P1. Okay, on based on time quantum or time sharing constraint here. So this type you will be seeing in a scheduling algorithm like your round robin, which you will see in a further videos. Okay, so now this multitasking will help that each process can execute in a in particular time. So there is no that disadvantage which we have seen in multiprogramming in your multitasking. So I hope this is clear with the multiprogramming and multitasking. Multiprocessing we already just saw with the types of multiprocessor system. So here the multiprocessing is nothing but we have more than one CPU or more than one general purpose. So we have CPU 1, CPU 2 and so on. More than 2 CPU is your multiprocessor system, correct? So whenever we have many different processes in your main memory that are ready to execute, so here I can put one process in one CPU, the second process in another CPU, and then the third process in other processes, so that here more than one CPUs are there, and one processors can be executed in one different processor at the same time. So that concurrency you can see, or the parallel execution of the processes is in your multiprocessing system or multiprocessing we can call this. So this is nothing but multiprocessing, which we have already seen in your previous video. Okay, so this helps you to gain for about 5 to 8 marks minimum. So you should know these definitions also. Sometimes along with this they may ask some other concepts also. So you should know the difference between multiprogramming, multitasking and multiprocessing. So the next topic, that is operating system operations. Here in this concept, the main important thing, that is dual mode operation. So dual mode operation is usually asked many a times in the previous question papers. So let's deal with that today. So here is the diagram for this. So always when it is asked for minimum 5 marks, it is asked, and maximum it is asked till 7 marks. So diagram is very important. So to know how to remember the diagram It's like just very simple diagram. I will go on explaining so that you people can even understand what exactly we have to draw in the diagram. First thing, you have to have a two different boxes. That is, you are going to separate your user and the kernel. So why the kernel? Kernel is nothing but your heart of the operating system. That is, so we can consider kernel itself as operating system. So user when wants to interact or wants to execute any of its application or any process, okay, so it cannot directly execute. That is what we have seen in your previous videos also. That is why we need operating system. Now in this dual mode operation, before going with this concept, we have to know about the interrupt, because OS is an interrupt driven. Now what is interrupt? You all know that there is some disturbance or distraction in between. Say for an example, if you really want to know what exactly is an interrupt is, suppose you are doing some art, or you're doing some listening to some music, or you're reading some novel, okay, while you were reading, your mom calls to you. I mean, she calls and she says that please go to the shop and get something for, like that. So that means the mom, I mean the calling what mom has done, okay, that is an interrupt to you. It's like a disturbance in between. Maybe you were reading some climax in the novel, and the meantime your mom is calling in between. So it's like a disturbance, correct? So that disturbance is called as an interrupt. Same way, even in your operating system, we have interrupts. So they are basically categorized into hardware interrupt and a software interrupt, where we all know that the term hardware interrupt is nothing but the interrupts that are generated by the hardware. Now when I say hardware, it's an hardware devices like your input devices like keyboard, mouse and so on. Okay, so this is an hardware interrupt, that is interrupt generated by the hardware. Now when I say software interrupt is nothing but it's also called as a trap, which we will be seeing in this dual mode. So software interrupt is nothing but an error that occurs while your program is executing. Say a best word for this is an exception. So I think you might have heard about the word exception. Exception is nothing but a runtime error that has been occurred during your program execution, correct? So that exception is nothing but your software interrupt. Now, why did I deal with the software interrupt and the hardware interrupt here is because whenever any program, okay, now let's see what is dual mode operation. So you will understand in this. Say dual mode itself says dual means two, okay, so dual mode operation. Now why we call this as dual mode? Because we are dealing with two different modes. One is the user mode and the kernel mode. User mode is nothing but at the user side, where all the applications are there and only the user programs can be interacted. But if suppose user needs something that is need to be executed, okay, so it may call some system calls, and that system calls cannot be executed at the user end. So all those programs are written in the operating system, that is your kernel, where it will execute and give back the result. So the main basic point what you have to write for here, that is for 5 marks. Say I will consider it for 5 marks because most of the time it is asked from 5 to 6 marks only. So 1 marks for your diagram. Basically, why I am considering only 1 marks, though it is so much, because here it is little bit more to write. Not much, but yes, something 4 to 5 points is required to write in this. So first part you have to write, or first point you have to write is your diagram. The second point you have to just write about what is user mode and what is kernel mode. Okay, user mode is also called as a safe mode, and the kernel mode is also called as a system mode or a supervisor mode or privileged mode also. Okay, and in that point only you're just going to say that user mode, its mode bit is represented as equal to 1, and the kernel mode where the mode bit is represented as 0. Now how to remember that mode bit for user is 1 only and for the kernel is 0? Now we all know that the kernel is nothing but the OS. So OS, when I say O remembers 0, okay, make that denotation, so you will be able to remember the kernel mode means bit is 0, that is OS. Remember like that. Okay, now in the third point, what are you going to explain? Here I prefer better give one example so that it will be easier for the understanding as well as to write it easily. Okay, now we all know that when we start a system or your laptop, the first program that will be loaded is your bootstrap program. Okay, now when the system will be booted. So when the system is booted, the bootstrap loader, what it will do? It will first load the operating system to the main memory. Okay, now when it is loading from your ROM, that is your system, that is bootstrap program is in the ROM, that is you all know that. Okay, so when OS is loaded into your main memory, okay, now the OS is executing. Yes, so when the OS is executing, so initially what will be the mode bit? It will be 0, correct? So when your system is booted, your OS is first loaded into the main memory. So OS is loaded into the main memory, that it starts execution. So your mode bit is 0. Now after it is loaded into your main memory, OS has started execution. After the execution, maybe CPU might get one task or one process to execute. Say suppose opening a WordPad and typing it. Now that process will start executing. Now when I am executing, I click on your WordPad, correct? I'm telling you the example, you can cut short it and write. So that process, when it is executing, while it is executing, maybe when some system calls are being called, like say open, read, write, close. These are many system calls which you will be seeing in the next video again. So this system call, now I say suppose I have called open system call. Now whatever I call open, okay, say this might be the function or the system call. Now this function body is written in the operating system. We don't know what exactly to do here. So that system call is nothing but an interrupt. It's been generated. Now that interrupt is nothing but a trap. Now when the CPU, which was first 0, correct, when the system OS got loaded and started executing, now when the CPU got the process to execute, it switched from the mode bit 0 to 1. Now while it was executing, again it got an interrupt. So that interrupt has to be executed. That is a system call that has to be executed. That will be sent to your operating system to execute that system call, because this function is written in the operating system. Now again from mode bit 1, it will be switching to mode bit 0. Now it will execute your system call. After it is executed, then it has to return to the process. Why it has to return? Because it has to execute the remaining instructions in the process. Okay, so that time again, which was in the mode bit, it will switch to mode bit 1. So in this way, this switching and going from mode bit 1 to 0 is nothing but your dual mode. So whenever the CPU says or it recognizes the mode bit 1, it says that it's the user is able to access, that is user has no direct access to the memory, right? So only user programs can be executed. If then the CPU, if it recognizes with mode bit 0, then it says yes, operating system is executing some of the system calls. When it will return, I will resume my work. So this is your dual mode operations. So you got to know what to write for the 5 marks. One is for your diagram. Second point, you have to write about the user mode and the kernel mode. Third, explain this example. with this, and with the fourth point you can explain, or before writing the first point about the user mode and the kernel mode, explain about the interrupt. What is interrupt? What are the two types of the interrupt? Then write about the user mode and the kernel mode along with the mode bit 1 and 0, and then one example and this diagram. So you are done with one of the 5 marks question, that is dual mode operation. Thank you so much for watching. Please do share and subscribe.